and welcome to VeEX Broadband Basics. My name is Mike Collins. I'm a product manager at VeEX. This series of videos is designed to provide you with an overview of the fundamental features of our CATV products. Every video will highlight features from our broadband field meters. Let's get started. This video series is about the spectrum analyzer mode in the CX380C meters. The CX380C offers a powerful spectrum analyzer with advanced technology to capture transient interference and power measurements across a wide frequency range. It features a large 7-inch high-resolution LCD with touchscreen controls for rapid perimeter adjustments. Horizontal and vertical markers display signal values instantly. The frequency range of the spectrum analyzer is 5 MHz to 1.8 GHz. Supporting DOCSIS 4.0 extended spectrum and upstream high split to 204. The spectrum analyzer has a noise floor sensitivity of -59 dBmV. From the main menu screen, select the spectrum analysis button. This will bring you into the spectrum analyzer mode. Before delving into the details of the spectrum analyzer, I will first review some of the settings associated with the spectrum analyzer in the main menu setup. In the main menu setup screen, there are two settings that pertain to the spectrum analyzer, the upstream bound and the spectrum mode. The spectrum mode setting has two types, standard and expert. Standard provides optimized settings for the spectrum analyzer to get your job done quickly, and expert mode is used for the industry veterans that prefer additional controls to the spectrum analyzer. Upstream bound, which is short for upstream boundary, this setting enables the user to set the upstream parameters that is used and will set the upstream's engines to the fast and best performing setup to capture upstream activity. Presets include 42 MHz, 65 MHz, 85 MHz, 117 MHz, and high split of 204 MHz. Standard and expert both provide the traditional settings such as center frequency and span, which can also be changed to start and stop, resolution bandwidth or RBW, the reference level, and V-scale. When the spectrum analyzer is set to standard mode, you'll see that there are some additional settings. There is a signal and resolution setting, and below the signal setting there is another field. This field reflects the signal level type that is selected. There are three signal types to choose from. You have burst, digital, and analog. For signal type burst and analog, the field below will show dwell. And for digital type signals, the field below will show average. When the signal type is set to burst, this is the best mode for measuring bursty signals in the return path, such as DOCSIS UCDs and OFDMA traffic, as well as intermittent and transient types of interference. The field below will show dwell, with three selections to choose from: fast, normal, and slow. The more you dwell on each frequency, the slower the sweep time is. So the more you dwell allows the spectrum analyzer to process more data. When the signal type is set to digital, this is the best for looking at QAM and OFDM signal measurements. The field below will show average. The user will have the ability to select three different settings: low, normal, and high. This sets the amount of averaging done on the trace data. The higher the averaging, the more defined the trace will look. When the signal type is set to analog, this is the best for measuring analog channels. The field below will show dwell. The only setting for dwell is normal. The resolution field has three settings: low, medium, and high. This sets the amount of data points for the spectrum. The higher the resolution, the more data points. The more data points, the finer the details. When the spectrum analyzer is set to expert mode, you will see the fields below are different. There are now a detector and sweep time field. On the right side, there is a couple on-off button and a preamp on-off button. The detector field has three settings: min, average, and peak. When set to peak or min, This will set the spectrum to display the peak signals or the minimum signals. When set to average, this sets the trace to show an average display. This also enables the spectrum to provide a power bandwidth measurement based on the vertical marker settings. I will cover this in an upcoming slide. The sweep time field enables the user to set the sweep time in milliseconds. There are two modes for the sweep time: automatic sweep time and manual sweep time, or indicated with an A or an M. Sweep time A indicates an auto-configured sweep time where the unit will automatically configure the best sweep time for the trace display. Sweep time M allows the user to manually set the sweep time. To switch between automatic and manual sweep times, simply select the sweep time field. This will change it back and forth. When the couple on button is set, the reference level and the attenuation are coupled together. Based on the reference level, the attenuation will be set automatically. When the couple off button is set, the user can set the reference level and the attenuation level independently. Also, the preamp button now can be turned on or off. Here's an example of a couple off setting to improve your measurements. In screenshot 1, you will see that the couple on button is activated, and the trace displays an upstream UCD burst traffic measurement where the levels extend beyond the top of the screen. In screenshot 2, when you switch the couple setting to off, both the reference level and attenuation can now be adjusted independently. In screenshot 3, you now can set the reference level to an appropriate point where you can easily view the tops of your UCD levels while maintaining the same attenuation. In expert mode, you can perform a total power measurement. To do this, set the detector to average type and then activate the vertical markers. By placing the vertical markers on the spectrum trace, this will enable the analyzer to measure the total power of the signal between the two markers. By placing the markers on either side of a QAM channel, an OFDM channel, or all channels in the spectrum, the unit will provide a total power measurement of the signal between the two markers. The total power measurement will be displayed at the top of the screen. Here are some settings to help the user view an OFDM channel. First, set the start-stop frequency of the spectrum analyzer to the parameters of the OFDM channel. For the standard mode, simply set the signal type to digital, the average type to high, and the resolution to high. If you are using the expert mode, set the detector to average, the RBW resolution bandwidth to 100 kilohertz, and manually set the sweep time to 3000 milliseconds. This will display the OFDM channel to where you can see the continuous pilots across the carrier. The persistence mode is a useful tool in the spectrum analyzer's toolkit. It is beneficial in detecting noise under a UCD or OFDMA carrier in the return path. To activate the persistence mode, first set up all parameters of the spectrum analyzer. Switch the meter to persistence mode by selecting the min-max button and then selecting the persistence button. Once the persistence mode is activated, the spectrum trace will display different color codes, signifying the types of signals being detected. For example, dark blue indicates a briefly detected signal, while light blue indicates a more persistent signal. The colors green to red represent the highest amount of signals present at that location. Utilizing the persistence mode is a powerful method for identifying ingress under a bursty signal in the return path spectrum. This concludes this video on CX380C and the spectrum analyzer. Thank you and stay tuned for more VeEX broadband basic videos.